project. So for this project, we made analysis forum of the sports car. Okay, first of all, I would like to present our group members. The first one is Muhammad Ahmad Ashraf bin Rosli. Second one is Tan Saiful. The third one is me, myself, Nur Afrika Jamrus, and the fourth one is Bambang. Okay, so I will explain about the outline first. The first one, we'll talk about introduction. The second one is methodology. The third one is discussion, and the fourth one is conclusion. Okay, so basically, finite element method is a numerical method for solving complex engineering problems. So for this project, we want to analyze the sport rims of the car, whether it will fail under certain boundary condition or will succeed for its operation. So for the analysis, we are using Finite software, and for the design, we use SolidWorks software as it is compatible for 2D and 3D design. Okay. And we analyze the structure geometry with few different load and conditions. Okay. The objective of this project is first one is to analyze the sport rim of the car under different kind of load and condition using our finite element method approach. The second one is to analyze critical point on the rim when a load is applied. Okay, the third one is to analyze the suitable material to be used. Okay, this is our Gantt chart. Firstly, we made the first meeting, then we discussed about the SolidWorks, the 2D drawing, and then we studied the Finite run. After that, we made a second meeting, then we determine the boundary conditions, determine the realistic applied load, mesh independent study, and we conducted meeting for data analysis. Then we made consultation with Dr. Nick, and the final one is we compile all the final.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad Ashraf. Today I will explain about the methodology, the step that we use to do the project. Okay, first and foremost, we do the design using SolidWorks. We design a frame, the dimension, the diameter, and so on using SolidWorks, and then we import our design into the Finite style. The purpose, first we import and then we do a cleanup. The purpose we do the cleanup is to ensure that the geometry is in good condition and there is no defect and so on. So the third one is when we do the cleanup, we do the pre-processing and meshing to the geometry. Pre-processing, we select the material type, we select the material properties and do meshing size. We determine our own meshing size from the biggest to the lowest meshing size. And the last part is we do the post-processing parts, that is we analyze the deformation and the contour of the geometry itself. Okay, next. Okay, this is our design analysis. We do the design in our SolidWorks. This is our front view, and this is side view, and this and at the top right, at the top left is our top view, and that is the isometric drawing. Next. Okay, as I mentioned before, this is our step in doing the analysis of the geometry. First, we import the geometry from the SolidWorks and then apply material load and constraint to the geometry. Third, we do the meshing geometry according to the specific size. And lastly, we analyze the deform and contour of the geometry. Based on this four figure, you can see that these are the flow and step that we use in order to analyze our ring to get the stress and the deformation of the ring itself. Next. Okay.
Good morning. Now I want to introduce myself first. My name is Tan Saiful. So right now we want to start doing our analysis. So before we doing our analysis, we want to determine what is our boundary condition first. So after several study, we found out that the both positions turned out to be the ideal position for boundary conditions. So by using the finite construct, we can set the 5 weight as the boundary conditions. So under one situation which the car is not moving, we call it as static conditions. And then we want to analyze our rings, how will the ring deform, and what's the force under the static conditions. So after we determine our static condition, we want to determine the property of the material of our study. So we are using the SSR tie-out sport ring, and then our subject of study is BMW 3 series. The weight is 1745 kg and the horsepower is 225 HP. So based on the information provided by BMW, the weight distribution is 50-50%, which means the distribution of weight is equal. So we can assume that each ring can support the equal mass of the car. So in our analysis, we are using force per unit area. So by using the formula pi times r plus dr square minus r square, we can find the surface area of the ring. And after we determine the area, the force divided by the area is the force per unit area exerted on the ring, which is 4738.38 Newton per meter square. So before we start analysis, we should do the massing first. So the mass we use is that mass. The element size is 0.5 and the mass angle coordinates is 15. And after we massing on all the surface, we found out that our number of node is 54082 and our number of element is 29715. So this is how the geometry turned out after we apply the force and massing. And the next is after we do our analysis. As you can see, there's different color which represent different value. So you see the green color, and the area with green color represent the area of ring which has the lowest stress, and the area with orange colors represent the area with higher stress. So we can see that this area will less likely to fail under the static conditions, while this area support the higher stress in our ring. So the maximum warm mixture stress is 172.8 megapascal and the minimum stress is 0.779 megapascal. So as I mentioned before, the color represents the amount of stress supported by the structure. And so we now to do a data analysis on the part which support the higher stress. So in the figure you see the orange color which I have selected represent the part which has higher stress. And then by using the software, we can get the table of the element. So there's a number ID of element, the color, and the mixture stress, mean stress, and warm mixture stress. So by using this table, we can see the amount of stress supported by the orange color element, which support the higher stress.
Assalamualaikum. Hello, hi, me again. Okay, now I will explain about the discussion about how we change the size of mesh. So based on my friends said before, he do about one meshing type of mesh. size of mesh, and he analyzed it. And now method is to explain on how we change the size of mesh and how it alter the value of stress. So in the table we can see the mesh size decreasing from 0.03 until 0.05. The decrement is about 0.01. We increase the size about 0.01 to see how the stress change with the size of mesh. So when we change the size of mesh, the smaller the size, the bigger the number of elements. You can see in the table. Based on the table, we have plot our graph, the conversion graph, that is number of elements against the stress value. If we can see, during the earlier about 6 data of the size of the number of elements, we can see it fluctuate in the smaller region, and then it up and it fluctuate again at about number of element about 80,000, and then it decrease and then decrease again. We get this result of the conversion. We didn't get the constant because the machine took long time, and that is we have to stop at the size of mesh 0.05, and then this is our conversion. It fluctuates. So next part is we try to use another different material, that is AISI 4340 steel, pure titanium, and Inconel 600. With this material, they have a different Young modulus, and with the different Young modulus, we have fixed the value of size of mesh and the element itself. If the size of mesh is the same, definitely the number of elements will be the same. And with this, we analyze the value of maximum stress against the Young modulus. As the Young modulus decreases, we can see that the number of maximum stress also decrease. The value of stress is linearly proportional to the value of Young modulus. So as a conclusion, from the simulation of the Finite mass run, the software shows how the load is being distributed throughout the rim tire. This gives us the picture of how load can impact the rim tire, and at the same time we can alter the shape or design of the rim tire to minimize this critical segment of the load in the structure. This means that in our project we have analyzed how load being applied to the structure of rim, and we analyze the stress and the maximum and minimum point in the rim structure. So our objective has been achieved as we have analyzed the location of the critical point when we apply the load. This has been mentioned by our friends Saifu at the discussion sector, and the last conclusion is the decrease the probability of the structure to rupture in a short time. We do the Finite mass run analysis because we want to analyze the strength, the properties of the rim, of the geometry, because in our daily life we do not want the geometry is being damaged or being ruptured if excess load is being applied. So that's the end of our presentation. Thank you very much.